All right, this video is kind of a supplement to the two intro videos that Tom Glenn did. There's just a few things that he did not walk through that I think are important for you to know before we move on. So the first thing that I believe you may have seen it, but he doesn't really talk about it, is commenting. Commenting can be done by entering this hashtag or pound sign or number sign on a line. Wherever you insert that, everything that comes after it is going to be ignored when you run the code that is on that line. So what this means is that you can leave notes to yourself about what each line of code does. You can also comment out lines of code that you're not using, or you think you might not use it, but then later on you decide you do need it, so then it's still there because you've only just basically turned off that code instead of deleting it. But the most important part is just actually leaving good, extensive comments in your code, reminding you exactly what that code does. Okay, the next thing is creating variables or objects. So you can assign a value to a variable, which is basically like the whole point of what we're doing. When you are naming your variables, it's very important not to use spaces or symbols. Other than the only symbols that R will tolerate is the period and the underscore. I try to stay away from the period, and I'm not really sure why. I think I've just always been taught that to use the underscore. I don't really know of any reason why you would not want to use the period. That's just kind of the way I've always done it, is using the underscore. So that's what you'll see a lot in my code. So this first little line of code here is given the name my value to, and this is called the assignment operator. So we're going to put the assignment operator here, and then the number 24. So we're assigning the number 24 to the variable my value. And there's a couple different ways you can run code. I think Tom talks about that. You can use this button up here, highlight the code, and then use this button up here, the run button, and it'll run the code. Or you can actually just command enter, or command enter on a Mac, control enter if you're on a Windows operating system. And you see that when I ran that, this populated over here in the global environment. So every time you create a new variable, it will show up over here. It'll give you the name of the variable and then whatever's contained inside of it. You can also create vectors, which is going to be a variable that has multiple values in it. You do this using the concatenation operator, which is the C, and then whatever your values are inside parentheses behind the C. So I've named this one my vector, and then use the assignment operator, and then I have C with 4 different values in parentheses. So when I run that code, you see down here in the global environment, my vector appears. And then it looks a little bit different. It's going to tell you each of the values that are in there, but it's also going to tell you the class of the variable. Every variable or object that you create in R is going to have a class. Numeric is one. Other classes you might see are character and factor. Off the top of my head, those are the only 2 I can think of, but I know there are more. I think integer is another one. Yeah, those are the only ones I can think of right now. And then I'll also tell you how many items are in the vector. So you've got 4 items, 1 through 4 here. If you don't know what type of class a particular object is, you can always use the command class and then the name of your object in parentheses behind it. So you see that runs and shows you down here in the console that the class of my vector is numeric. You can also just run type the name of a object into the script and run just that. And what will happen when you do that is it'll populate what the items are in that particular object down in the console. And the console is this this corner here. Also, I didn't say it already, but your R may be set up, your RStudio may be set up differently than mine. I don't think this is the default way that it RStudio downloads. In fact, I know it's not, because I have rearranged mine several times before landing on this particular way of organizing it, and this is just kind of my preference, but I think Tom talks a little bit about that in his video. So when populating a vector, you can also use the colon to give you all the numbers in a range. So in this case, we're looking at numbers 1 through 10. So my vector with the assignment operator and then 1:10 is going to overwrite, because anytime you use the same name for an object and then put new data in it, it will overwrite the old data. If I run that, now I'm going to get, now it's changed the class on me. It's now an integer class, and I suppose this is just because it's a bunch of consecutive numbers instead of a weird random string of numbers. And it's telling me that I've got 10 items in there, 1 through 10, and then it tells me what each of the items in there are. So technically you may run across every now and again where you see code, not mine, but maybe somewhere out there, somebody using the equal sign rather than the assignment operator. I think early in ours early days, that was something that was used, but pretty much everybody has gotten away from that, just to avoid confusion with the double equals operator, which we'll get to a little bit later. So here, like I said, for best practices, let's just stick to this assignment operator, which is the less than sign with the dash right next to it. We can also index or get elements out of a vector by giving the position of the element in the vector. So if you were to say my vector and then in brackets the number 5, what R is going to return for you is the 5th element in that vector, which in our case happens to coincidentally also be 5 because we put in 1 through 10 as our vector. However, if we changed our vector to say 25 through 30, now we see that this is overwritten again here, and we have the numbers 25 through 30 in there. And then we were to run this my vector get element 5. Now it's going to give us 29 because it's the 5th element in the vector. Occasionally you're going to want to clear out your workspace. There's not much here right now, but this will get very cluttered the more you work in R, and it can get just really confusing. So there's a lot of reasons why you might want to clear data out of there. To clear a specific item, you can clear one item at a time if you want. And to do that, you use the command rm, and then in the parentheses behind rm, you say the name of whatever your object is that you're trying to clear out of there. So in this one, I'm telling it to remove my value. So if I run that code, you see that my value no longer appears in the environment over here. The next little piece of code will remove everything from memory over here in the global environment. And I do this a lot. I do it every time I use R. Basically, when I start a new something, I want my environment empty. Some people will let things just like sit in their environment like forever because they're like paranoid to take them out of there. But if you have done like you're supposed to do, which and set your working directory and you're saving things in your working directory, which is something we'll get into in the next video, that shouldn't be a concern, and you should be able to keep your global environment tidy. But there are reasons why You may not want to clear everything out of there. You might want to save certain things in there. We won't do any models that are this complicated in this class, but in upper level classes, you may have a model that's really, really complicated and it needs a lot of computing power, and that might take a long time to run. So if you haven't already saved that model somewhere else, because you can actually save even models that you run to your working directory, but if you don't happen to have done that and you want to just leave it in your environment, or you forget it's not saved to your working directory and you clear it out, then you're going to have to rerun that model and it's going to take forever and it's kind of a pain in the ass. But anyways, so this is the code that you would run to clean out your entire environment. You don't really need to remember that though, because there's this nice little broom right here. So this and this do the same thing. You just click on that. It's going to ask you, are you sure you want to remove all objects from the environment? And warn you that this can't be undone, which is great because it's just that fail safe for you if you don't actually want to do it. I'm going to say no here because I'm going to go ahead and run this code. So note that does not give you the warning, which is another good reason not to use the code and to use the little broom, because it'll kind of give you that double check. Okay, assignment operators are next. This is just kind of just to let you know, like what, obviously greater than and less than are what they are. If you're doing mathematical calculations within R for one reason or the other, and we will eventually, greater than and less than are just the greater than and less than sign. Equals is going to be a double equal sign. The exclamation point with equals after it is going to be the equivalent of not equal. And then the less than sign with equals next to it is less than or equal to. And then similarly, if you flip it and you have the greater than symbol there, that's going to be greater than or equal to. I have all of this behind it. I'll go ahead and run them so you can see, like, if you ran those, you're going to get like, yes, 5 is less than 6. And then it's going to tell you, no, it's false. 5 is not greater than 6, and so on and so forth down the line. And so when possible, R is always going to do its best to make two quantities comparable, even if one is a string and the other one's a number. So a string is a string of text. So, but if this string of text, and when you enter something in quotes, R will recognize it as text rather than a number. So that's why they look different here. But even if you have text and a number, if they're the same, R is going to recognize them as such. However, once you assign a variable or a value to a variable, then it will compare the value in the variable, not the name of the variable. So if you have I and you assign that to the number 5, or create a variable of I with the value of 5, and then you try to run I equals the text I, then it's going to tell you, no, it's not, because I is not equal to 5. I, the letter, is not equal to the number 5. It's going to substitute 5 over here. I think, oh yeah. So, but if I clear that out of there and run this again, now it's just telling me it's not even found. Assign a string. Oh, I see what, okay, so if you were to put the I, if you were to assign I to I, and then run I with I in the quotes, then it's going to tell you it's true. So here's a few functions that you're going to see a lot throughout the semester. Well, a fair amount throughout the semester. Ones that are very useful for manipulating data. So let's create a vector out of 1, 2, 3, 4, and 5. So we have my vector over here. The function actually, length, and then if you put the name of the vector in the parentheses behind it, is going to tell you how the length of the vector, so how many items are in the vector, and that'll just populate down here in the console. It'll tell you 5. Now, this might seem stupid, like why do we need to know? We can just look over here and see 1 through 5, but when you have big, long, huge data sets that have thousands of items in them, we can use this function in a lot of ways, actually. We can also use the sum function with my vector in the parentheses behind it to add all of those numbers together. So that's, may initially seem more useful than length, but you'll find later on that you probably use length a little bit more than you do sum. Okay, so we'll clear that out again and move on to the 5 basic data structures in R, which is it's important to know like how R recognizes data. So we've seen values, and we've seen vectors, but there's 3 others that we'll talk about. But first, I have a little bit of extra code down here to go over the fact that the value that goes into any particular object does not have to be a number. So here, my value is 24, and it's a number, and if we ran class my value, it's going to tell us so. But we can also put text into variables, of course, because we have a lot of things that will wind up in our data that are not numbers. So here we're going to tell it that we want my value to be equal to dog. You've seen that that's been overwritten over here. Now we have dog. And if you check the class now for my value, it's going to come back as a character instead of numeric. Again, we already saw the vectors, but similar to a value, we can have numbers in a vector, or we can also have text. So you see that we've got a character vector, character object with 3 items in it. Those items are Sophie, Callie, and Maisie. Another useful tool is the REP function, which allows us to repeat a specified value a given number of times in a vector. So if we want to create a vector that has just repeats the number 23 50 times in it, that's what this function here does. So if you run that code, you see we've got a repeated values vector now. It's numeric because we've populated the number 23 in there a bunch of times. We see that it's got 50 items in it, and then we can see most of the items. Not most, but some of the items. Here we already talked about length up top, but we can see my vector has 3 items in it, but like, for example, repeated values, since we can't see the whole thing in the environment, this is one instance where length would be a little bit more useful. It'll count them up for us and tell us there's 50. Matrices are what you think they are if you've ever had any upper level math. It's a 2-dimensional. The vectors are just 1-dimensional strings of text or strings of numbers. Matrices are 2-dimensional. You've got rows and columns. It's a much more common type of data structure in R than vectors. just by themselves. Actually, what you run into mostly is data frames. A matrix can hold only numbers, whereas data frames can also hold vectors of text. So you can create a matrix by using the matrix function. So I've created my matrix using the assignment operator. The function is called matrix, and then in the parentheses behind it, you're going to tell it what gets stored in the matrix. So I'm telling it the numbers 1 through 10 need to be stored there. You're going to tell it the number of columns that you want. So we want 5 columns, and the number of rows. We want 20. And then the last argument in this function, so in R, this is known as a function, where you've got a command or the name of the function and then several arguments within it. So you've got the data function, or the data argument, the column argument, the row argument, and then this one is going to tell it how the input should be added to the matrix. So it says by row equals true, which means that when it populates the matrix with the number 1 through 10, it's going to start and fill each row. So it's going to go 1 through 5, 6 through 10, 1 through 5, 6 through 10, all the way until it's finished at the bottom of the 20 rows. If this said false, it would go the other direction. It would populate by column. So it would start with 1 at the top and go 2 in the first column of the second row and 3 in the first column of the third row, and so on and so forth. But so we can run this and see that we get this matrix, which now shows up here under data rather than values. My matrix, it's integer, is the object class. It has 20 rows and 5 columns. So now that we've gone 2-dimensional, we see like this is just we've got the 1 through 3 and 1 through 50. Now we've got 20 rows, but we've also got 5 columns. And you can see the first, bit of data there. If you actually run just the name of the object, it'll show you the whole thing. And you can see that it populated it by row 1 through 6, or 1 through 5, 6 through 10, like you tell it to. We can also use these brackets to index or get different items or elements out of the matrices in a variety of different ways. So if you tell it, in my matrix, I want you to get the first row, and if you don't leave anything out, if you leave everything after the comma blank, then it's going to get all of the columns. So important to remember, rows come before the comma, so in the brackets you want rows, columns. So here you're going to get just the first row, and it'll populate down here 1 through 5. Or alternatively, if you say give me the 5th column, shows you 5, 10, 5, 10, or this column right here. Or you can give it a specific row and a specific column, and it'll just return the one number for you, 3. We can also create new variables out of pieces of matrices. So all of these things, you can extract these things and then you get these different items here. But if you then give it a name, so my matrix 3, 3rd row, 3rd column, now you've got this value over here, 3L. Or you can create a whole vector. Now you see that VAL has been overwritten by this vector that is the 3rd column, so it's all the rows, the 3rd column, so it's 20 items, just 3s and 8s. we're not gonna, this won't be in your code. We don't need to talk about that. That's just some extra stuff that really isn't gonna help us this semester. This is some old script that I haven't looked at in a while, I guess. But, okay, we can move on to data frames now. Data frames are similar to matrices, only they can hold text as well as numbers. So we're going to start off and we're going to create 4 vectors: student ID, grades, class, and free lunch. You see we're doing this in a variety of ways, things that we already talked about above. The concatenation operator with the sequence of numbers, or just individual elements spelled out, and these are text, so they go into quotes. Or we can do this fancy schmancy, repeat this so many times and then repeat the other one so many times. And then the last one is just saying to repeat the word true 10 times. So we've run all this code. Now we've got these 4 vectors that have shown up over here. Actually, let's clean out some of this other garbage real quick. Run this again. Okay, we've got our 4 vectors over here. Now we can actually put these vectors together to make a data frame. Data frame is pretty much one of the most commonly types of data, or one of the most common data types used in R. They're useful because they can hold multiple types of values. Like I said, the matrices can only hold numbers. And yeah, we're gonna, so this, they're also easy to index because you use this $ operator, which we'll show you down here how that works. And they're the most common input type for statistical packages and methods in R. So everything that we do is going to, when we actually start working with statistics, is going to use the data frames. So the data frame data.frame is the function to create a data frame. The different arguments in here are you can have as many as you want that tell it which vectors you're smushing together. So we've got 4 arguments because we have 4 different vectors we're putting together, plus 1 more argument that says strings as factors equals false. For some reason, when R uses this function data frame, it wants to coerce these vectors into a data frame and then make all of the text strings object class factor, and that, like, we'll use that later on in the semester. The class factor, there's some advantages to using it like that, but you'll want to make that decision later when you're coding, and you're going to want to start off with everything just as characters. So if you say strings as factors equals false, that's what it's going to give you. So now we have taken these 4 vectors down here, and you can see that they have been like folded up into this data frame MyData, which has 4 variables and then 10 observations. And you can also run this over here, and it'll show you in the console what the entire data frame looks like. Very rarely are you gonna, I don't know, sometimes you might have data that's that small that you can look at, but very, very little of the data that I work with can you actually see in the console like this. You can also click on My Data, and you can get this up here, this little tab that opens up, looks a little bit like an Excel spreadsheet. But to be honest, even that, I think Tom Glenn talks a little bit about this in his video, it's not very user-friendly. So it's good for a quick look if you need to see something, but if you really want to get a look at and a feel for your data, it's better to open it in Excel or something like that. Okay, once we have a data frame, we can also add columns to it using the assignment operator, or another way to think about this is you want to add a new variable to your data set. So we do that by instead of just having our object name, we have our object name, or data set name, and then the connection operator, the little $sign, and then a variable name that we give it here. So there's two parts to this now. We've got the data set name and the variable name, and then the assignment operator, and then how we populate it is similar to the things that we've already done up there. So now if we add this, see now we have our data set has gone to 5 variables, still 10 observations, and if we want to look at it again, you see we've tacked on this names column also. So you can also rename columns. So like if you decide later on that you didn't like these particular names, you can use this call names function and then tell it the name of your data frame, the assignment operator, and then similar to like if we were going to create a vector, we use the concatenation operator, and then it's going to replace in order each of the column names that already exist. So whatever is the first column name is going to become this student ID with the capitals. Basically, we're just capitalizing a lot of this stuff. So if we run it, you can see that all of these have now overwritten with the different spelling with the capital letters in there. We can also set row names, but this is not very common. So we can do that, and then if we want to look at the data like this, you see that it's like given each row a letter down the side here. Or if you actually just want to run it, you can see down there it's giving us a name to each row. But again, very rarely are you going to do this. There's not, and a lot of times you're going to wind up, you might get some data that has that you want to undo, but we'll get into that later when we run across it, if we run across it. Indices, or indexing works the same as for matrices. But so we can do it like this, like we did above, but you can also oh yeah, it'll work for this one. It does not work very well for this one. So what we need to do is actually use the variable names now. So instead of saying my data and give me column 1, we actually give it the full variable name. Even though that works like this, the same way it does for matrices, it's kind of good practice to get used to doing this, because then you'll remember that you actually have to do this. So instead of just getting true, you actually get the third item of this variable. The final data structure is a list, and I'm kind of just going to glaze over this because we won't use it. I never use lists. I've done some things that are more complicated, or where in classes that I've taken that are higher level classes where I've worked with them in the class, but on my own data, I've really not done much of anything with lists. But still important for you to know. Think of this. So if a data frame in a matrix is a 3-dimensional structure, or 2-dimensional structure, a list is maybe kind of like a 3-dimensional structure, I guess, or yeah, kind of like a 3-dimensional. So a list is a object that can hold many data frames, or it can hold data frames and vectors, or it can even hold lists and data frames and vectors, or multiple lists. So we'll run this code. So it's telling it to create a list with a length of 10. Yeah, so we got an empty list here that has 10 vectors in it. That's just empty. there's nothing in it. And then you can also just create a list using the variable or using the function list, and tell it to put all of these different things in it. So this time the list has several things in it. It has the number 10 in it. It has a variable that is holding just a single element, which is dog. It also has a vector in it that has a string of numbers 1 through 10. And then it has a whole data frame in it. Our data frame that we have up here, my data, has also been included in this list. Or you can just create an empty list. So now it's just my list of 0. There's nothing in it. And then there's, these other things that you can do to it. But again, I'm not going to bother going through all of this stuff now, I don't think, because you won't probably use it. At least not this year. Oh, the one thing I will say is that if you were to want to extract any of the elements of a list, instead of using just the brackets that we've been seeing in a data frame or a matrix or a vector, you use the double brackets. And then the last thing I'm going to talk about is packages. So if you've done the reading already, you should be familiar with this idea, but packages, and I think Tom Glenn talks about it a little bit too. So as R has grown over the years, it's open source software, and people have written extensive code to do particular functions. They will create packages that essentially can hold that code and kind of run it behind the scenes for you, so that you don't have to run all of the code, write script for every single little detail. So if you've never used a particular package, first you have to install it. You only need to do this once. You use the function install.packages, and then the name of the package in quotes, and then you're going to add this comma dependencies equal true. What this does is load any other packages needed for this one to run. So sometimes packages rely on other packages to function, and if you don't have those other packages loaded, then the package you're loading won't work. So if you do this dependency equals true, R will automatically install all those other packages that the package that you want is relying upon. And this particular package, Rio, is something that we'll get into in the next video when we talk about importing data and using data. That one relies on several packages, because what Rio is this nice little easy one. It's just a handy package for importing data, because you can import data from a lot of different data types. So think like Excel documents or CSV or SPSS files. It can import any of those files, and the command is always the same. The structure of the command is always the same, and it's all within that package. Whereas each of those data file types actually has a different package and a different function structure to import the data if you were not to use Rio. So SPSS uses the package Haven, and it has a certain format, the way it wants you to enter everything. Then there's also a a package called Foreign, where that one will import, I think, CSV and Excel. So, and then they each, even within that package, the Excel and the CSV, I think, are different formats. So this is just handy because it's just less to remember. So I'm not going to run this because I already have this package installed, but you could run that. And then once the package is installed, you have to open it to use it. And you do have to do that every time you run a new session of R. So once you've got it installed, you don't have to do that anymore. But every time you open R, you're going to have to open the library for whatever package that you want to use. and you need to open the package with the command library. Okay, and then the last thing I was just going to hit on is this, and this is in the text. There's a little RSouls tip 3.4 about disambiguating functions. Okay, so sometimes you're going to run into two different packages that have a function that has the same name, but they do different things. So there's for example, there's a recode function in both the HMISC and CAR packages, and I think we're probably going to use both of these at some point in time this semester. We won't use recode out of these packages, but we will use these packages. So if you happen to have both of those packages opened up in your session of R and you want to use the recode function in one or the other, you need to tell it which function to use it out of. Otherwise, it's just going to pick itself. Maybe it's going to pick the wrong one, and then you've got a mess on your hands. So the way to tell it specifically which package to use is to say package, or is this structure. So for example, use the CAR package to open the recode function like this. Or if you want to use the one out of the HMISC package, then you would put that in the front there. I'm not going to run that either, because I don't think I have these in packages installed right now. Long story about that. Okay, so next video we will be learning how to import the data sets that you guys have out on Canvas. But that's it for this one.